Hello, my name is Giovanni Garcia. I will be discussing how we sense and perceive the world around us. Sensation is when our sense organs have been activated by a physical source of energy from the environment. In contrast, perception is a process of recognizing and interpreting sensory stimuli. A stimulus is when a physical source of energy has produced a response in a sense organ. Absolute threshold is the lowest level of a stimulus a sense organ can detect. For example, if you play music and lower the volume to zero and slowly raise the volume, the moment you detect the music is when it has crossed your absolute threshold.
Be alone when I leave her. I like it better that way.
By now, it should have already crossed your absolute threshold. Difference threshold is the smallest amount by which two sensory stimuli can differ in order for an individual to perceive them as different. For example, if you listen to music with the volume at 25, if you were to increase the volume to 26, you might not notice a difference. But if you were to raise or lower the volume significantly, you will hear a difference.
When my hood getting to the money, the pedal never broke. Came a long way from the ghetto though, but west side right on time. Only thing for sure, east side right on time. Gunning through.
Weber's law means it's easier to notice a change in a low stimulus than in a high stimulus. For example, if you change the music's volume from 5 to 10, you can hear a difference in the low stimulus than if you were to adjust the volume from 30 to 35.
Soon as I get home. Dear baby, it's me again, stuck inside this max pen, trying to pay my debt for all my sins.
Sensory adaptation is a decreased responsiveness to the stimuli due to constant stimulation. Like when you check your phone in the middle of the night and the screen's brightness blinds you until your eyes adapt to the light. That's sensory adaptation. I'd like to now present you to Ashley Lopez.
Do you ever wonder how things get processed from your eyes to your brain, or why we can see colors, or maybe why people can't see color? Well, vision all starts with light, the physical energy that stimulates the eye. Light comes into the eye as a form of electromagnetic radiation waves, which are measured in wavelengths. The size of wavelengths correspond to different types of energy. The range wavelengths, called the visual spectrum, for you and I to be sensitive to is relatively small. Other mammals, such as sharks and fishes, have higher sensitivity than humans. The ray of light being reflected off an object first travels through the cornea. The pupil is a dark hole center of the iris. The size of the pupil opening depends on the amount of light in the environment. The dimmer the surroundings are, the more pupil opens to allow more light to enter. A small pupil greatly increases the range of distance at which objects are in focus. With a wide open pupil, the range is relatively small and details are harder to discern. Once light passes through the pupil, it enters the lens, which is directly behind the pupil. The lens bends the ray of light so that they are properly focused on the rear of the eye. The lens focuses light by changing its own thickness, a process called accommodation, meaning it becomes flatter when viewing distant objects and rounder when looking at closer objects. Finally, as the image travels through the pupil and lens, it reaches the retina. Here, the electromagnetic energy of light is converted to electrical pulses for transmission to the brain. But due to the physical properties of light, the image reaches the retina upside down. There are two kinds of light-sensitive receptor cells in the retina, cones and rods. Rods are thin, cylindrical receptor cells that are highly sensitive to light. Cones are cone-shaped, light-sensitive receptor cells that are responsible for sharp focus and color perception, particularly in bright lights. Cones are concentrated on the part of the retina called the fovea, which is a particularly sensitive part of the retina. If you would like to focus on a specific interest, you would automatically try to center the image on the fovea to see it more sharply. The rods play a key role in peripheral vision, which is receiving objects that are outside the main center of focus, and in night vision. When light energy strikes the rods and cones, stimulation of the nerve cells in the eye trigger a neural response that is transmitted to other nerve cells in the retina called bipolar cells and ganglion cells. Bipolar cells receive information directly from the rods and cones and communicate that information to the ganglion cells. The ganglion cells collect and summarize visual information, which is then moved out the back of the eyeball and sent to the brain. Through a bundle of ganglion axons called optic nerves from each eye meet at the point roughly between the two eyes called the optic chiasm, where each optic nerve splits. When the optic nerve splits, the nerve impulses coming from the right half of each retina are sent to the right side of the brain, and the impulses arriving from the left half of each retina are sent to the left side of the brain.
Sound is the movement of air molecules brought about by a source of vibration. Sounds travel through the air in wave patterns similar in shape to those made in water when a stone is thrown into a still pond. Sounds arriving at the outer ear in the form of a wave-like vibration are funneled into the auditory canal, a tube-like passage that leads to the eardrum. We call this the eardrum because it operates like a miniature drum, vibrating when the sound waves hit it. The more intense the sound, the more the eardrum vibrates. These vibrations are then transferred into the middle ear, a tiny chamber containing 3 bones, the hammer, the anvil, and the stirrup, that transmit vibrations to the oval window, a thin membrane leading to the inner ear. Because the hammer, anvil, and stirrup act as a set of levers, they not only transmit vibrations but increase their strength. The force of sound waves on the oval window becomes amplified. The middle ear then acts as a tiny mechanical amplifier. The inner ear is the portion of the ear that changes sound vibrations into a form in which they can be transmitted to the brain. The human sense of smells permits us to detect more than 10,000 separate smells. We also have a good memory for smells. Long forgotten events and memories, good or bad, can be brought back with a small whiff of an odor associated with the memory. The sense of smell is marked when the molecules of a substance enter the nasal passages and meet the olfactory cells, the receptor neurons of the nose, which spread across the nasal cavity. More than 1,000 separate types of receptors have been identified on those cells so far. Each of these receptors is so specialized that it responds only to a small band of different odors. The responses of the separate olfactory cells are then transmitted to the brain, where they are combined into the recognition of a particular smell. The sense of taste involves receptor cells that respond to 5 basic stimulus qualities: sweet, sour, salty, bitter, and umami. Although the specialization of the receptor cells leads them to respond most strongly to a particular type of taste, they are also capable of responding to other tastes as well. Ultimately, every taste is simply a combination of basic flavor qualities in the same way that the primary colors blend into a vast variety of shades and hues. The receptor cells for tastes are located in roughly 10,000 taste buds, which are distributed across the tongue and other parts of the mouth and throat. The taste buds wear out and are replaced every 10 days or so, and also change over time as we get older. The sense of taste differs significantly from one person to another, largely as a result of genetic factors. Some people are super tasters and are highly sensitive to taste. They have twice as many taste receptors as non-tasters, who are relatively insensitive to taste. All of our skin senses, touch, pressure, temperature, and pain, play a critical role in survival, making us aware of potential danger to our bodies. Most of these senses operate through nerve receptor cells located at various steps throughout the skin, distributed unevenly throughout the body. For example, some areas such as fingertips have many more receptor cells sensitive to touch and as a consequence are notably more sensitive than other areas of the body. The most extensively researched skin sense is pain. Pain can be devastating, yet a lack of pain can be equally bad. We can hurt ourselves and not even know it, which can cause way more harm to our body than we expected.
Perception is the manner in which our brain receives and processes stimuli. Perception is what also allows us as humans to perceive the world in different ways. Gestalt proposed that the brain uses different levels of organization when processing information. The first law is the law of closure, where the brain, due to a lack of information or experience on the subject, fills in the holes with information that is often inaccurate.
Okay.
The law of closure is oftentimes why we as humans have a different perception of what is actually occurring in reality. This is often the reason why people exaggerate their stories. It is also why our perception of things such as shots and roller coasters are worse than they actually are. Proximity is a principle which states that when things are physically close together in space and time, our brain thinks that they're connected. This principle explains why when people see a string of Christmas lights, rather than seeing individual lights, we see continuous lines. It also explains why in this picture, which is actually just a collection of dots of different sizes, we see a Dalmatian. Similarity simply means that our brain groups things together that look similar to each other. This principle is the reason why we can group a collection of circles and squares differently. It is also the reason why we group people of different races and nationalities into their own separate categories. Our brain, despite all the hard work it does, tends to slack off. Simplicity is the idea that rather than looking for the most complex explanation of a stimulus, the brain detects the most simplistic perception of that stimulus and then moves on. This is the concept behind most optical illusions. Our brain wants to see the simplest explanation of the picture, so we do not see the hidden image. Top-down processing suggests that we form our perception starting with the larger object, concept, or idea, before working our way down towards more detailed information. In other words, top-down processing happens when we work our way down from general information to specific information. Bottom-up processing is also known as small chunk processing, and suggests that we attempt to perceive stimuli by starting with the more fine, smaller details of the stimulus, and then building upwards until we have a solid representation of it in our minds. Humans have the unique ability to view the world in 3 dimensions. Because there is a distance between the eyes, a slightly different image is seen by each eye. The brain integrates the 2 images into a composite view, but it also recognizes the differences in the images and uses it to estimate the distance of the objects. Our depth perception is what allows us as humans to judge the distance between ourselves and an object. It is also the reason why we were able to tell that this mural done on the ground in chalk is 3-dimensional. So that was chapter 3, Sensation and Perception. Thank you so much for watching, and yeah.